So this presentation is about, in this presentation, authors try to address the different types of explanation and how they impact on the different users who have different expertise. This work was presented in the IUI 2021 conference, which you are familiar with, by Maxwell. Yeah, okay. So before starting this work, I would like to ask you the question: what, in your opinion, is explanation is all about? What is an explanation?
A description of something, describing how something works, what it does, what its purpose is, something along that line.
Yeah, exactly. Any more ideas? Okay, so according to Miller, he proposed that explanation is about answering why question. So this is something that we human are familiar with. We often ask these type of questions like, why didn't the treatment work on the patient? Why was my loan rejected? And these are, everyday explanation that we usually use to, reason about something. But then arises a question: what is a good explanation? What attributes actually makes the explanation really good and understandable for the users? What do you guys think?
One that can answer your questions well.
Okay.
One that is given as part of a conversation. If we are talking about the same Miller, I think that.
Yes. I think that's a really good. Yeah, that's a really good one. Any more ideas?
Yeah, I guess it's one that helps the audience understand the events.
Yeah. So yeah, these are all good answers, but I try to shortlist 3 important characteristics that I found quite relevant to the paper that I'm going to present. So one notion is that explanation are contrastive, and we often humans tend to answer things like, how would the prediction have sorry, just give me a how would the prediction have impact on the input X had been different. So so instead of just saying that why my algorithm has produced something, we would ask why it didn't produce something else. So we often ask these type of questions. So another interesting attributes that makes the explanation really good is explanations are selected. People do not expect explanation to be exhaustive, but rather they are only interested in handful of reasons that causes a certain event. And the last one is that explanation are social, and that's the reason that why I included this aspect of the explanation is because this is quite relevant to the work that I'm going to present. And it says that they are part of the conversation or interaction between the explainer and the receiver of the explanation, and the social context determines the content and nature of the explanation. So this social context actually determines which audience I'm gonna address, and then this target audience actually determines which type of explanation suits them. For instance, if we are designing these explanations for laypersons, then perhaps they will perceive these explanations quite differently as compared to when we design these explanations for expert users. This is how our mental model works. So as I said earlier, every users have a different mental model about the explanation type. For instance, some user may like the visual aspect of the explanation more understandable, while others may like the textual description of the explanations. So in this paper, actually the authors try to answer these same questions. What impact do different types of explanation have on the interpretation of the predictive algorithm? And they also studied these different types of explanation through by moderating by incorporating the user expertise in that. So they studied in which way are the differences in the interpretation influenced by the user expertise. And lastly, they studied what explanation modality might potentially minimize the difference in the interpretation. So it might possible that the maybe textual description might be useful for the laypersons, but not for the expert users, or maybe the vice versa. So they try to study whether is there any modality that can minimize this difference in the interpretations. So in order to design these good explanations, they actually built on this prior work by Homan, which describes different attributes of designing a good explanation. And they actually use 3 of them. The first one they use is the C local, which says that local instance explanation, which is quantifying each parameter's contribution to an instance prediction. So we are actually interested in which parameter actually contributed to the instance prediction. And then the other attribute that they used was this C counter, which is also called counterfactual counterfactuals. Given an instance, ask what if question to observe the effect of changing a parameter on the prediction. And then the last attribute they used was C importance. Feature importance, give the parameters that are most influential to the overall prediction. So actually this paper comprised of 2 iterations. In the first iteration, they actually compared the textual and visual explanations. And the tasks that they used were really straightforward. The authors evaluated explanation of predictor models in the context of predicting the average reading time of a magazine article, giving the following input parameters. So the word count, topic relevance, article size, picture use, and on what page the article is on. And the goal was to reduce or improve the average reading time. So the visual explanation that they designed was based on this concept called partial differential graph. And I guess you guys are already familiar with that. So it is a 2D graph that shows that how much influence input parameter has on the output y, and it is described like this. On the right part of the screen you can see, and they use all of the attributes that I described in the previous slides, C local, C counter, and C importance, and they incorporated this within this design that you can see on the screen. So the first one is C local, like which denotes the C local capability, like which attribute actually contributed to the overall prediction. And then C counters by indicating how the output would differ by changing the input. And then the C importance by showing the weight of the selected parameter. Here you can see they included kind of a bar, progress bar, that shows the importance of the selected parameter. And user can perhaps like navigate between different parameters and see which one impacted the prediction more. And in the textual explanation design, they just added the textual explanation, like the current value that the user can see, like the topic is highly relevant, denotes the C local capability, and how the selected parameter influences the prediction denotes the C counter and C importance. Like they use this template that you can see on the screen right now. The current value of the parameter is highly relevant or not relevant, or maybe slightly relevant. And then they use this high, medium, and low attribute to kind of address this last parameter, which was C importance, whether it's a high, low, or medium. And then they use this C counter to determine whether this was a positive effect or the negative on the prediction. Uh, in the first study, they actually hired participants with different expertise. So 10 experts, 10 non-experts, excuse me. And then you can see the demographics on the screen. And it was a within subject study. That means that both participants interacted with the textual and visual explanation one after another in a random fashion. And there were 2 exploratory tasks and 2 tasks to gauge the insight. At the start of the study, users were asked to interact with the dashboard as if they were a news article writers. And there were 2 tasks they adopted from the prior research, where first task was to actually give 2 parameters with a high impact on the prediction output. And the second task was what input parameter would you change and how to maximally increase the predicted output. So in terms of the output or measures, they use the ease of use and time needed to perform the task on a 5-point Likert scale. They also administer the think aloud protocol to kind of gain more insight about how the participants think about the explanation. And then they also ask 2 additional questions, like which type of explanation do you prefer and why? In what use case would you use these explanations? These are the results. So on the left side, you can see the correctly answered tasks. These results were quite surprising because, as you can see, if you look at the user type, expert actually answers more correctly, correctly answers whether it's for a textual or visual explanation, while the lay users were only successful in the case of textual explanation, but not in the visual explanation, because only 5% answer correctly in the visual explanation. But when the authors asked them to give their preferences about their preferred explanation style, most of the users preferred visual explanation, despite the fact that the lay users committed more mistakes in the visual explanation. But they still preferred the visual explanation over the textual explanations. Okay, so the additional question that they asked were 2, which explanation do you prefer and why? And for this, most of the expert users actually prefer the visual explanation because this resonates well with their working style. Most of the experts say that they actually work in the they actually work in types of the tasks where they have to interact with sort of graphs or visualizations. So they prefer, that's why they prefer the visual explanation, while other prefer visual explanation because they thought that it is more efficient. They can easily find the information that they're looking for, while some of them prefer visual explanation because it gives them a quick overview of the information. Then some users did not actually like the visual explanation, and among them, 1 was expert and 2 were lay users. They didn't like because, according to them, the visual explanation is kind of overwhelming for them. And some lay users actually advised to add additional text to actually to properly comprehend the visual aspect of the explanation. In answer to the second question, in what use case would you use the explanation? Most of the expert users and also the lay user like it because they can examine the existing instance and kind of use this knowledge to improve the current instance prediction. For instance, one of the users said that maybe they can, based on this explanation, they can better design the article with more pictures, for example, with the more concise words to improve the average reading time of the article. And some prefer it because they thought it helps them to better understand and the model. And some prefer both of these aspects. So in the discussion section, they actually highlighted the reasons why the lay users prefer the visual explanation and while performing worst in that. So the first reason that they provided is that actually the non-expert user, through their think aloud protocols and other logs that they analyzed, they came on this conclusion that the non-expert users were adopting this strategy known as system one thinking, or also called inductive reasoning, where it is fast, heuristic based, and low effort, but it leads to more errors. And it's also known as the confirmation bias. For instance, confirmation bias is a kind of bias where people tries to confirm their existing notions or belief by selectively looking at the particular information or knowledge. So that's why it leads to the more errors. And also another reason that they provided was lack of exploration due to reinforcement effect. The reinforcement effect usually occurs when you introduce someone to the unfamiliar knowledge or information, and then when they understand that okay, they cannot properly comprehend this knowledge, they try to skip the information, and that results in lack of exploration and lack of understanding. For instance, in the case of visual explanation, when they analyze the think aloud protocols, one of the users said that this graph shows me the value of this article in relation to the other articles, which wasn't the case. In case of the expert users, they actually adopted kind of deductive reasoning, which is also known as system two thinking, which was slow, analytical, and high effort, where expert user actually kind of first came up with some of answers, and then reason about their choices, and then selectively reduce this set of answers and reach to the conclusion slowly and gradually. Although it was slow, but it was less prone to the biases and errors. So the idea that they proposed based on the first iteration study was, what if we combine the both textual and visual explanation into one interface, which they call the hybrid explanations. They use the same concept that I described in the previous slides, but they, in addition to the visual explanation, they also add some text to kind of explain these graphs. For instance, the partial dependence graph was interpreted wrongly by the lay users. That's why they added the text underneath the graph. And also they added the text underneath the this progress bar. And then they ran another study with 10 experts and 10 non-experts. They were not the same users that they used in the first study. There was a different set of users. And in this time, they actually compared the hybrid explanation with the visual explanation, because in the previous study, they noted that lay users committed more mistakes in the visual explanation. So, and also there were some differences they want to minimize by answering this research question 3 that I stated earlier. So they compared hybrid explanation with the visual explanation. They use the same set of exploratory tasks, and they also employed the think aloud protocol to kind of understand how they think about explanations. And this time they actually got some improvement as compared to the previous study. As you can see on the right 2 bars, the lay user also did some improvement in terms of interpreting the models more correctly. And also there was some improvement in the expert, in the interpretation regarding the expert users. They also interpreted like there was 5% improvement for the expert user as well. So the results that they got based on their think aloud approach was the following. For the expert user, hybrid explanation confirmed their preconceived beliefs about what information the visual explanation holds. And so they actually confirmed their preconceived beliefs. while for the lay users, they corrected their wrong understanding, and it increased their exploration and increased the confidence during interaction. So the two takeaway messages that they proposed was the following. Take user expertise into account as a moderator for understanding the explanations. That was the most important finding that they got. And users can unknowingly interpret visual explanation in an incorrect way. And that's why it's important that we provide them with additional aids, with additional text, or maybe some other sort of explanation, like or training tools like tutorials, or some additional text that can help them to properly interpret these visual explanations. And with this, I conclude my presentation.